of the circuit, that if we have a basic circuit in which we have installed the diode, now how this circuit is going to work? Let's see that we have a diode, and with the diode we have a resistance, and with the resistance we have some DC source which is being connected in the circuit, right? Now if we say, let's suppose the DC source is E, the potential that is going to be developed across the diode, we say, let's suppose VD, and the resistance which is being connected in the circuit is R. So we say the potential which is going to be developed across the resistance is VR, right? Now, as you can see that this is the positive side of the DC source and this is the negative side of the DC source. So what will happen, that if the biasing potential E is going to be greater than VD, so then we have going to be a current which is flowing in this direction, right? And what we say, let's suppose the current flowing in the diode is ID, right? So how this circuit is going to behave? So the first thing first, that if we are going to apply KVL to this circuit, so applying in a loop KVL, what we are going to get? Anybody?
Sorry,
What
E
we are going to get?
is equal to VD plus VR.
J.
E is equal to VR plus VD.
Okay. So when we apply KVL, so according to this, E is equal to VD plus VR, right? Okay, ji. Or what we can say, VR is equal to ID into R. Are you with me?
Yes, sir.
Okay, ji. Now, what we can say, that if we say that we have seen the characteristic curve last time. So what we say, we have VD and we have ID, right? And we have seen that the characteristic curve of the diode is something like this, right? And normally this is our 0.7 volts for silicon, or if we say it is made up of germanium, so it is going to be 0.3 volts. For GE, for silicon, it is 0.7 volts, right? Now, if we see this equation, which is over here, E is equal to VD plus VR. Or we can say that replacing VR with ID into R, so the equation is going to become E is equal to VD plus ID into R, right? If we say, that VD is equal to 0, what is going to be the, sorry, it is, okay. So if we say VD is equal to 0, what is going to be the value of ID?
0,
We
sir.
divide by R.
If
We
VD
divide
is
by R,
equal to
sir.
0, so put the value in the equation, we are going to get E is equal to 0 plus ID into R, right? Or this means we can say ID is equal to E divided by R, provided what we say that VD is equal to 0. Are you with me?
Yes, sir.
And if we say ID is equal to 0, if ID is equal to 0, so in the equation, if we put this, we have E is equal to VD plus 0 into R, right? Or this means VD is equal to E when ID is equal to 0. Are you with me?
Yes, sir.
Now, what we have obtained with this, because with this we have obtained the limit of this circuit. And the limit of this circuit, it can be shown on the curve which we have over here. We have this curve, right? This is the characteristic curve, right, of the diode. With the same thing, with these 2 points, which we are obtaining it over here, that if we put VD is equal to 0, we get ID. And if we put ID is equal to 0, we get the point for VD, right? So this means if we say we have VD and we have ID, right? So if VD is equal to 0, so this means we are at this point, right? If VD is equal to 0, so we are at this point, right? So at this point, the value of the current is equal to E divided by R. Are you with me?
Yes, sir.
बात समझ में आ रही है जी?
Yes, sir.
If VD is equal to 0, the value of the current is E divided by R, which we have obtained it over here, right? And if ID is equal to 0, the value of VD is equal to E. So this means if ID is equal to 0, so the value of VD is equal to E. So this means these 2 points on the graph is actually showing us the 2 extremes of this circuit, which is over here. Right? For this circuit, we are having these 2 extremes, right? So if we are going to connect these 2 points, so this is going to provide us the load line. right? And on the same graph, if we are going to draw the characteristic curve, this is the characteristic curve, which is the VI characteristic curve of diode, right? So if we draw this curve on the same graph, so this means we have this curve. Are you with me?
Yes, sir.
बात समझ में आ रही है जी?
Yes, sir.
So one is
Sir, what is load line?
okay. So one is the load line or the straight line which we are getting due to the network, right? And the other is the characteristic curve of the diode. The two lines where they meet is basically called the Q point. And Q point is basically the point of operation of the diode within the circuit, right? So this means that depending upon, so your circuit is going to be working on this load line, right? And depending upon where the characteristic curve of the diode is going to meet this straight line, it is going to be the point of operation of the diode, right? So this means that the diode will be operating on this specific point of the meeting point between the straight line and that of the characteristic curve. Now, depending upon what is the situation of the diode, so this is going to provide us the point of operation of the diode. Because you know, at different point of operation, the diode is going to behave differently, right? Do you know this? बात समझ में आ रही है जी?
Yes, sir.
क्योंकि आपको पता है कि डायोड जो है डिफरेंट पॉइंट्स पे डिफरेंटली बिहेव करता है, राइट? तो जहां पे ये लाइन मीट करेगी कैरेक्टरिस्टिक कर्व के साथ, तो वो बेसिकली पॉइंट होगा डायोड के ऑपरेशन. नाउ दिस लाइन slope can be changed depending upon the value of the biasing potential. Because if you see the value E, which is the biasing potential, and the value of the resistance. So depending upon these two, the slope of this line, which is dependent upon E by R, right? So if we are going to change the value of resistance, if we are going to, let's suppose, increase the value of resistance, so this means this line, which is over here, so if we are going to increase the value of resistance, so this means this line can move over here, right? And if it moves over here, so the slope of the line will be something like this. Right? If the value of resistance is going to decrease, so this means the slope of the line will be something like this. Are you with me?
Yes, sir.
आज समझ में आ रही है जी? So if the slope of the line is going to change, so this means the point of operation of the diode is also going to change, right? So this means the Q point or the point of operation, or which is also called the quiescent point, the point where the diode is going to operate. So that point is going to change. When that point is going to change, so this means the behavior of the diode at that specific point is different from the behavior of the diode at some other point, right? So due to this, what we are actually getting, we are actually getting the, let's suppose if I say, that at the point of operation, if I say this is the Q point, so this means at this specific point, we can say this is VDQ, and the current, if I draw the line over here, so the current will be IDQ, right? So in this way, we can have the specific value of the current and the specific value of the voltage across the diode, right? So that specific point is called the Q point, and due to that, we are getting the IDQ and VDQ. Question? Anyone? Any question?
No question.
Okay, Ji. So with this, there are few examples which are also given in the book. So if you just go through it, the examples are example 2.1, example 2.2, example 2.3. So they are just giving you the idea that how the point of operation is dependent upon the network values, as well as depending upon if you use the diode as an ideal diode, or if you use the diode as the equivalent diode model, right? That if you use the, so in the equivalent model, you know that the diode is behaving as we have a DC source, which is equal to 0.7 volts. So the diode is not going to turn on unless and until the value across the diode is 0.7 volt. And in case of the ideal model, this means that the diode is just behaving as a switch. So whenever the switch is closed, so this means the potential across the diode is 0 volts. So, and it will allow the current to flow through it, right? So these are just simple examples. If you just go through it, so you will have the clear idea what is going on. Okay, ji? With this, there is also a few more examples, which are just the basic circuit examples. Example 2.4, 2.5, 2.6, and 2.7, 2.8, right? Just go through it. That is going to give you the clear idea that how the things are working. Question? Anything?
No, sir.
Sir,
Okay, ji.
ये
Ji,
slope in slope increase or decrease इसका क्या मतलब?
किसका?
ये slope जो R के साथ increase या decrease होता है, इसका क्या मतलब?
Okay, coming back over here. If you see that what we have the circuit element, right? Circuit element means we have resistor, we have diode, and we have the biasing potential over here as E, right? So if the value of resistance is going to increase, let's suppose we say we change the value of resistance over here, right? If we say previously it was, let's suppose 10 ohms, so we increase it to 20 ohms. Let's suppose, I'm giving you just an example. Okay, ji? So if the resistance
sir.
is going to increase, right, from 10 ohms to, if the resistance is going to increase to 20 ohms, right? Or if I say from 10 kilo ohms, it is being increased to 20 kilo ohms, right? So if
Yes, sir.
the value is going to increase over here, so what is going to happen to the slope of this line. What will happen to the slope of this line?
Sir, it will change.
It will change, right? Because if the value of this R, if the value of this R is going to increase, so this means this total amount is going to decrease. And when this total amount is going to decrease, so this means the value of ID will be somewhere here, right? And when it will be
Yes, sir.
somewhere here, so this means this point or will be a straight line will be something like this, right? And
Yes,
when
sir.
this line will change its slope, so this means the point of operation, the Q point is also going to change now. The Q point will be somewhere here, right?
Yes, sir.
So due to the change in the circuit elements, what will happen? The point of operation of the diode is also going to change. And once this will change, so this means the behavior of the diode is also going to have a different outcome as compared to the previous circuit elements, right? So this means the point of operation will change. So this means the behavior of the diode will change. This means that the total outcome of the circuit will be different as compared to the previous case. So this means the load line plays a very important role in the point of operation of the diode. बात समझ में आ रही है जी?
Yes, sir.
Okay. Any other question?
No question, sir.
Okay. Okay. So now, what we can see that if we have a circuit, we have a circuit that we have a diode and we have a resistance R. And previously what we have seen that we had a DC source, right? So if we replace the DC source with an AC source or so AC is, we say it is VI, right? And we are obtaining the output across the resistance as V naught over here. Are you with me?
Yes, sir.
So AC source is V, and what is the AC source is normally it is of something, a sinusoidal waveform, right? A sinusoidal waveform, and we say this is VI, right? So we have the positive cycle and we have the negative cycle, right? ठीक है जी? AC source का तो पता है ना?
Yes,
Yes,
sir.
Okay, so one is a DC source and one is the AC source. So in the AC source, we have a sinusoidal waveform. And normally the sinusoidal waveform is being depicted as VI is equal to Vm sine of theta, right? You have studied this in your PWE course, right? ठीक है जी?
yes.
Okay, so once we have this situation, so where Vm is actually representing the peak value over here, right? ठीक है जी? Now, once the AC source is being applied over here, so this means in the start we have the positive cycle. So the positive cycle indicates that this side of the source is positive, this side is negative, right? And what we say, we consider the diode as an ideal diode. Right? So when we consider the diode as an ideal diode, so this means that when the positive cycle comes, so the diode is going to behave as a closed switch, right? And a closed switch means that what will happen to the output? Anyone? What will happen to the output? Output क्या होगी जी? For the positive half cycle.
सर पॉजिटिव हाफ साइकिल ही होगा.
So for the positive half cycle, if we consider the diode as an ideal diode, so this means we have something like this. That the switch is closed, right? And we have the positive half cycle over here. So the output will be across R. V naught will also be positive half cycle, right? बात समझ में आ रही है?
Yes.
Now, when the negative half cycle comes, when this negative half cycle comes, what will happen? That at that specific point, the diode behaves as an open switch, right? So when the negative half cycle comes, so this means this end is now negative, this end is positive, right? And when the negative half cycle comes, this means the diode will behave as an
Open switch, sir.
the diode will behave as an open switch, right? And once the diode is behaving as an open switch, so this means no current will be flowing across the diode. And when no current is flowing across the diode, so this means V naught will be, this means V naught will be actually a flat output, right? So if we combine both of them, so what will happen that the output will be for the positive half cycle, it is going to be a positive half cycle, and for the negative half cycle, it is going to be flat output. Again, when the next cycle comes for the positive half cycle, we have a positive half cycle, and for the negative half cycle, we have that output like this, right? So it is something like this or off. ठीक है जी? Question?
No question.
So this kind of the behavior of the diode is called a rectification, right? That converting the sinusoidal waveform into a unidirectional waveform is called rectification. And once the rectification is done only for one of the cycle, it is called half wave rectification. ठीक है जी? So this is basically called the half wave rectification. Right? I know you have studied this before as well. Okay, ji? So this is just a refresher which is going on. Ji Umer. You want to say something?
Sir, can you just repeat it? I lost my connection.
Ji, acha. Okay, so the behavior over here, what we are getting is that for a sinusoidal waveform, we are getting only the positive half cycle at the output and the negative half cycle is being taken out. So this means we are converting a sinusoidal waveform into a unidirectional waveform. And such behavior of the diode providing this kind of output is called rectification. And as the rectification is being done in only the positive half cycle or in only one of the cycles, so this kind of rectification is called half wave rectification, right? It is called half wave rectification. Okay, ji? Right? Now, the point over here is that if you see that what is the average value over here? So if you see that what we are getting over here, that for one complete cycle, the duration is 2 pi. Are you with me? For one complete cycle, the duration is 2 pi. Right? No. Maximum value is Vm. बात समझ में आ रही है?
Yes.
Because one complete cycle takes place in what you say 360 degrees, and in 360 degrees you when you convert into pi, so it is 2 pi or 2 pi radian, right? So if we want to see that what is the average value of the output which we are obtaining it over here, so how we can find the average value? V average for over the duration of 2 pi. Anyone? How we can find the average value? जी एवरेज वैल्यू हम किस तरह फाइंड करते हैं? किसी भी चीज की एवरेज वैल्यू हम किस तरह निकालेंगे?
दोनों क्रिएट करके जितने क्वांटिटी से इस पे डिवाइड करेंगे इसका तकरीबन ये पॉजिटिव ही आएगा सर.
Okay, so if you see to find the average value, what we can do, we can check out what is the area under the curve. So the area under the curve is basically the positive half cycle, and if we divide it by the total duration, so this is going to give us the average value, right? Is this thing fine? So to find the area under the curve is from our mathematics knowledge. This means we will have the Vm sine of theta d theta, and the duration of this is from 0 to pi, right? Because from 0 to pi we have this sinusoidal signal, right?